Okay, so in this activity we're going to complete the first 7 problems, and then we will finish up this activity in the next class. There's some specific things I want to talk about. I want to be in class to have those discussions with you, but I feel pretty comfortable that we can work on at least the first 7 problems. So once you go ahead and begin with problem number 1, and the question they're asking here is, can you estimate what you think the value of z might be? What answer you think that would be? And then discuss that with a partner, like your person you're paired up with. And then we're going to talk about the 3 trig rules that we use for right triangle trig. So this hopefully will look very familiar from your work in geometry. And we're going to also look at a table that is generated using those rules and try to answer that question there in problem 4. Some of the problems that will follow are going to be applying the trig rules in all 4 problems here. And then that's where I want to have you stop. This is a pretty short lesson overall. We'll come back on next class and I'll have you begin with this as an opening problem, and then I'm going to talk about what happens when we get some very large angles, as we have one angle is a right angle, but then the second angle is getting close to being a right angle. What happens to sine, cosine, and tangent in those situations? Then after that, it's really about 2 more practice problems and the activity's done. So this is a pretty short activity overall. So hopefully, again, we'll finish up pretty quickly at our next class. So go ahead and complete number 1. Turn the video off, and then when you're finished with it, turn it back on. So in this problem here, we don't have any rules yet. You may recall some of the rules from geometry, or maybe some of you had the opportunity to do some work of this type of problem in middle school. But one of the things that they were looking at here or thinking about is the fact that we just finished a discussion on a 45, 90 degree triangle, that if this was 3 and this is 3, then I would multiply the 3 by root 2 to get that answer there. So these angles here are not 45 and 45, but they're pretty close to 45. So z would be somewhere very close to 3 root 2 as an estimate. So if I take 3 root 2 and stick it in the calculator, that's 3 times the 1.41 is what we came up with the decimal approximation in the last activity. When we did this, when we built the squares, and then I asked you to turn the square roots into decimal numbers. The 1 by 1 square had a diagonal of root 2, and that was 1.41. And then when we did the 3, that came out to be approximately 4.2. I think it was 2.4 is what we came up with when we rounded it. So that's an approximation for the length of z. It's about 4.24. All right, so the 3 trig rules. Tangent is the opposite side over the adjacent side. So it's the trig rule that we do not use hypotenuse. Sine is the opposite side over the hypotenuse. And then cosine is the adjacent side over the hypotenuse. Probably the biggest issue that I run into with students, actually 2 biggest issues. It's number 1, an unwillingness to label the sides to make sure that they're identifying the opposite, the adjacent, and the hypotenuse correctly. And the other is showing work. In other words, setting the problem up and actually going through the steps to show that the answer you're coming up with is correct. And it's one thing if you're doing the problems and you're getting all the answers right. It's another thing when you're missing a lot of the answers and you're still refusing to do the work. So please be willing to set the problems up and show the work, or be willing to label the lengths either as opposite, adjacent, or hypotenuse, so that you can hopefully come up with the correct setup. So the way that I had the conversation with students is if I look at the angle that we're looking for or using, which in this case is theta, the side that didn't get shaded blue is called the opposite side. It's always opposite the angle. So if I shade the two sides of the angle, the side that doesn't get shaded is the opposite. The hypotenuse to this point, hopefully you should be able to identify. It's the longest side of a right triangle. And then the third side is called the adjacent side. So I generally, when doing triangles, I will always start with the opposite, then I go to the hypotenuse, and then the adjacent is always last. And I will shade the two sides of the angle, the non-right angle, and the side that doesn't get shaded is always the opposite side. Now, based on the rules here, if you go ahead and label the three as sine, cosine, tangent, and it's asking you to, after you label them, do you see patterns between the different columns? So go ahead and label the top, and then start looking for some patterns, and then have a conversation with your partner about what patterns you have seen, and then turn the video back on when you're ready to continue. So the adjacent hypotenuse, this is the cosine column. This is opposite hypotenuse, that would be the sine column. And then opposite adjacent, that would be the tangent column. So a couple of things I'm hoping that you saw. I'm hoping that you saw that, for example, in the sine and cosine column, that the answer shows up twice. So 0.985 shows up in two different locations. The 0.940 shows up twice. The 0.866 shows up twice. So hopefully that's something that you noticed in this. What's critical here in terms of a pattern is for the 0.985 for cosine, it showed up at 10 degrees, and at sine, it showed up at 80 degrees. For the 0.940, for the cosine, it showed up at 20 degrees. For the sine, it showed up at 70 degrees. For the 0.866, it showed up for 30 degrees for cosine. And for the sine, it showed up at 60 degrees. So if I would choose some decimal number, some decimal number that's in this table, for example, such as so that it shows up both in sine and cosine column, what would be true about the angles? If, let's say, if this angle was 42, then what would the sine angle be? If I would choose some number, again, so that the angle for cosine was, let's say it was 71 degrees, then what would the sine be? If I choose something that the sine answer is, let's say it's 3 degrees, what would the cosine angle be? Can you look at the previous three and see a pattern between the cosine and sine angles that are giving us the same angles or same answers, and then be able to identify what the other answers would be for these three here? So go ahead and turn the video off. Think about it, write down your answers, talk to your partner, see if your partner sees the pattern in the same way, and then turn the video back on. So I'm hoping that you saw that if you took the two angles and added them together, they add up to 90 degrees each time. So I'm hoping that you chose here, 48 degrees to get to the 90. I'm hoping that here you chose 19 degrees to get to the 90. And I'm hoping that here you chose 87 degrees to get to the 90. So by using, they're called complementary angles, by using a pair of complementary angles for a right triangle, the sine of one angle and the cosine of the other angle will actually give you the same answers. Alright, in problem 5, there's 2 of them here. They're asking you to use our trig rules from problem 3 to figure out the answers to for x and for y. So, if you would go ahead and with your partner, try to set these problems up. Is it sine, cosine, tangent? Do you remember once the problem set up how you would solve it? And then turn the video back on. I'll go through the first problem and then give you some time to try to work on the second problem. If you are feel like you've successfully completed them, then move on to problem number 6. In problem number 6, they're actually asking you to find all the missing information. So if you're not given, let's say, a missing angle and let's say 2 missing sides, then you need to find those 3 numbers. So in the end, we want to have hopefully 3 angles and 3 sides for the triangle. So go ahead and work on the, problem 5. If you feel good or comfortable, work on problem 6 next. Turn your video back on when you're ready to look at the first answer to number 5. Alright, so the angle that we're working with here is 17 degrees. So this side over here is the opposite side because it's the side that didn't get shaded blue. The hypotenuse is the longest side, and then the adjacent side is what's left. So in this problem here, we're using those 2 sides, the adjacent and the hypotenuse. So I'm hoping you chose cosine, because cosine of theta is equal to the adjacent side over the hypotenuse. So if I did this problem, its cosine of 17 degrees is equal to 10 divided by x. Now there's different ways of doing these problems. I'm going to be honest with you, when I do these problems, I always do, when I solve for length, I always set up a proportion and I always cross multiply. And again, I'm saying to you there's other ways of doing it, but this is the one way that I always do it. So if I cross multiply, it's going to be x times the cosine of 17 degrees is equal to 10 times 1. And then I'm going to divide both sides by the cosine of 17 degrees so that I can get x by itself. So x is equal to 10 divided by the cosine of 17 degrees. Now my calculator, when you turn it on, you press the DRG button right here. Make sure degrees is highlighted, not radians. If radians is highlighted, then arrow to the left, highlight the degrees and hit enter to get it to recognize it. And then you simply put in 10 divided by the cosine. So 10 divided by the cosine of 17 degrees. And the answer is approximately 10.457. Alright, so for this last problem here, number 5, I am looking for y. And so if I would shade this angle here, that would make this side opposite because it hasn't been shaded. That's a 48 and that's a 42, which makes that 90 degrees. So that means the 7 is the hypotenuse. And then that means the third side is the adjacent. Keep in mind that these rules only work if the triangle is a right triangle. So if you don't have a right angle, you need to make sure that there is a right angle in that triangle. So we are doing these 2 sides here. So if you didn't set the problem up based on the information here, set the problem up. Use cross multiplication as my suggested step and see if you can come up with the right answer for the opposite side. Turn the video back on when you're ready to continue. Alright, so if I cross multiply here, this is a sine problem, opposite hypotenuse. So sine of my angle is equal to opposite of hypotenuse. I cross multiply. 7 times the sine of 48 degrees is equal to y times 1, which is y. So this time I just put in 7 sine of 48 degrees, and the answer is approximately 5.202. Alright, there are 2 problems left, and so like the previous activity, I'm going to leave these 2 for you to work with a partner on, and I'll call this problem's homework. See if you guys can figure out the answers using trig to problems 6 and 7 bring those answers back next class.